Hi everyone. Today's starting of the class will be a little about theory regarding GIS. So this whatever the information I'm gonna share to you, it is about how the GIS data is actually processed. By processed, I mean, for example, if in journal you talk about an image, you know that a image can be a PNG, it can be a JPG, it can be a GIF, right? So similarly, there are some standards. So there are some standards in GIS. For example, if I say that rasters should be limited to only these formats. So there should not be a possibility that tomorrow a new company comes in and they make a new format. So that would be difficult for like there needs to be a standardization of things. Okay. Now I have created a worldwide software maybe. It opens up a PDF. Okay. So the worldwide standard for using that PDF is .pdf. What if someone new comes up and he creates a new format .gdf? Okay. So that none of the softwares will be able to open that, right? So there needs to be a standard formats. There are some limited formats. You cannot go beyond these formats. Okay. So how these things are regulated in GIS, how these standards and what is spatial data infrastructure. Okay. So today we will have a look about all these generic things about GIS. Okay. Hmm. Now you understand that spatial data is more important than ever now, because in the past it was not so important, but with the future and with the coming trends, we have been using it everywhere and it is growing, right? So the spatial data is getting bigger and bigger. Okay. So because of that we have spatial data and we have the attribute data that is attached to it, that is the metadata, right? Now spatial data describes the natural and built environment in which citizens live their lives. Okay. So what it means is we are basically taking your environment and we are turning it into a digital format, right? It describes the natural environment and built environment in a digital format, and we are able to analyze it to understand different goods and services. Okay. So it provides a meaningful point of common reference when overlaying and analyzing data from multiple sources. So, for example, if you are working with landslides, so you have digital elevation model, you have the water moisture, you have different layers, and using them, you are overlaying them and you are creating a analysis out of them. Okay. It is just the basic relevance of spatial information, right? Now, as I said, the spatial data has exploded. Just imagine how much, how many people in a single time might be using Google Maps for navigation. Like crores and crores of people at one time are using Google Maps. So similarly, applications are increasing. Blinkit, Zomato, everything is coming up. So they all have this navigation build system, right? So more than ever, GIS is exploding. The spatial data information is exploding. Like it is increasing more than ever. Now, there is something called as spatial data infrastructure. Now, it is very important to understand what is spatial data infrastructure. Now, if I talk about your city, okay, maybe the city in which you live in, okay, so, or maybe the state where you are living in. So, if I talk about the infrastructure, you will tell all the buildings, all the houses, all the roads. Okay. So, all the units that constitute to that particular state, they are called as infrastructure. For example, if I am living in Punjab, so the highways, the multinational companies' buildings, the hospitals, that forms the infrastructure. Similarly, when you are working in GIS, whatever your data is, okay, maybe you're doing a project. So in that project, whatever you had your data, maybe you had a vector file, maybe you had a raster file. So that data is the infrastructure, right, of your project. So maybe I'm working with, for example, I have the uh, ATM points in your city. Okay. So uh, if I have to define the infrastructure, it would be the first the vector points, that is the ATM points, and then the attribute, right? So if I have another layer, similarly, all those will form the infrastructure of it. So just for example, as I said, for a city, the highways, the buildings, they all form the roads, they form the infrastructure. Similarly, when you're doing work in a GIS, everything in that project, everything constituting that project, it is a infrastructure to that project. Okay. Now, to understand how infrastructure there, I will make a correlation. Now, if you are building a highway, there is a certain quality standard the government says, right? There is a quality standard. So if you are using a cement of low grade, which is not allowed by the government, so you are doing something wrong, right? So you have to follow the standards. So similarly, when you are forming data in GIS, what is happening? You have certain standards. For example, I'm defining a name. So I have been given option, maybe in attribute I'm defining a name. Now I have the option to either select string, to either select float. So I cannot choose anything else out of other than this. So I have to go through the options. I hope you understand that part, that the infrastructure in GIS, the spatial data infrastructure, right? So whichever things constitute to this infrastructure, all those things have certain standards. Okay. And based on that standards, there are some possibilities that are predefined, and they have been predefined so that just the very generic thing, they have been predefined so that it itself forms a standard. You cannot go out of that standard. Okay. Now, I would like to give another example. So, for example, you have a bulb holder at your home. Okay. You go to the market, you bring a bulb and you take the bulb and put it in the bulb holder and it works, right? So you just go to the market and you bring a bulb. What if the bulb holder was not of a standardized size? Because the government has put a standard on it, there is one single size. If there was not a standard, every company would have created their own bulb holder, and you all then, for example, if I bought a Philips bulb, it would not have been working with the Anker's bulb holder. Okay. But the government has standardized the bulb holder. So that is why what is happening, whenever you go and buy any bulb, you are able to use that bulb on that bulb holder. Okay. Similarly, what is happening in GIS now, for example, let us talk about vectors. Just an example, let us talk about vectors. So you have a shapefile. You you have been given the options that you can use it a shapefile, or you can use a KML, or you can use something called as GeoJSON. Okay. Now these three files, they are interconvertible. What it means, that you can convert SHP to KML, you can convert KML to GeoJSON, and they are interconvertible. Okay. So now the standard is that you are using a file that is interconvertible into each other formats. For example, there comes a new data format in the market which is not convertible to SHP, or SHP is not convertible to it. Okay. it will break the standardization procedure. The standardization in this is that the data should be interconvertible so that they all can be used in a software, right? So, for example, if I'm QGIS, I'm using QGIS. So just think of QGIS as the bulb holder, okay? And SHP, KML, GeoJSON, they are the bulbs of different companies. So we want that all of them should be working in QGIS, and they should be interconvertible also, right? I hope you understood why standardization in GIS is important. Okay. Now, use of GIS became prevalent during the 1980s. So in 90s, 80s, this field started developing. Okay. People started understanding that there should be something as GIS. It will help us do analysis and everything, right? And uh, it led to a need to be able to exchange data and metadata between different GIS formats. Okay. Now, there are some de facto industry standards, for example, that developed. For example, Shapefile was developed in 1990s. So by default, we are using shapefiles. No one is saying that it should be default, but by default, we are, because it is so old that it became a default. Now, there is something called as Open Geospatial Consortium. Now, if you are working in the field of GIS, you need to remember this name. It is, for example, ISRO and NASA in space technology. Similarly, for GIS, we have OGC. It is very important to remember the name of OGC. It is one of the governing body that how GIS standards will be. Okay, it regulates the standards. Now, what I mean by regulate is, I told you that, for example, if you have a vector file can only be available to you in certain formats. That is shapefile, KML, GeoJSON, some certain formats, maybe 10 formats, for example. So, OGC is the body that regulates that, yes, this GIS data format is allowed. You can use the data in this format. SHP is allowed. You cannot create another, or you cannot go out of the defined regulation of OGC. Okay. Now, OGC has many members. It started in 1994 because there was a need to understand that for exchange of data and metadata, there needs to be some standardization. Okay. So it currently comprises of 475 companies, government agencies, and universities. Aims to enable geoprocessing technologies to interpolate or plug and play. Okay. OGC has standardized 50 plus specifications. For example, GML, KML, WMS, WFS. Okay. Now, first, as I told you, you need to remember what is OGC. Okay. So, if you have read chemistry, there is like a body IUPAC that gives the nomenclature, right? So, they are the ones who decide the name for the chemical formula. So, similarly, OGC is the one who decides how something has to be produced in GIS. Like they have given some certain standards. Okay. Now, maybe if you know buffer, what buffer is, okay, what buffer is in vector. So it is defined by them when any software company has to put a buffer analysis in their software, it should mean the definition what they have defined. It their buffer cannot be different from other companies' buffer. Okay. Buffer word has been defined in their dictionary, you can say, in their book of law. So you have to follow it. So similarly, all the things in GIS, they have prepared a regulation for it, a standard for it, a standard of procedure for it. So, uh, as I told you, now OGC has everything under their guidelines, but because they have to create it in a standard format, and there is another agency in the world that is called as international standard organizations. Whenever you create some kind of standards, okay, so you have to register your standard with the international standard of organizations. So, for example, uh, the bulb holder I told you about, okay, so it is a standard. The government has registered it with ISO, and in ISO there is a documentation. There will be a number given to it, maybe ISO ABCD 123 something, right? So that documentation, it it is related to these rules that should be followed when that bulb holder has to be created. If I am a new company, I want to create bulb holder. Okay, I want to create bulb holder in India. So I have to go to this ISO, look for that standard, and follow it. I cannot create a bulb holder of my own will. I have to create a bulb holder that is of the size that is given in the standard book. So they create standards. So for example, in GIS, whenever if you remember in QGIS or something, whenever you have a data, just a moment, let it open. Okay. So for example, this is one shapefile. Okay. Now if I open the attributes, here in attribute, you can see there is a data here. Okay. Now every data has a type. For example, if I select this, let me first deselect it. What I mean is, for example, if I add a new column here, right? So you see that there are certain options. I can either add an integer, I can either add a decimal number, I can either add a text, date, boolean, right? So I have been given this options. There is nothing outside of it. So this is a standard of this metadata. This is written somewhere. Whenever someone is about to create a software or something, they need to add these things here because it is a part of the standardized metadata of GIS. Okay. So, for example, this. So, for the same documentation, right? For the same documentation, this is available the metadata documentation that the data, how the metadata of a data, this thing should be defined, how attributes should be defined. There is a documentation about it. This is that documentation. So maybe if I'm opening a new software similar to ArcGIS and QGIS, I'm creating a new software. So I need to follow these guidelines. Okay. So if you just simply Google it, right? Just a moment. 19115. So if you Google it, it says it is an international as I told you, ISO standard defining the schema for describing GIS, providing a common framework for metadata. Okay. So anything that you do with the styling, anything that you do with the uh, attributes, it is all defined in this ISO. So in this, so now you can just imagine there must be many different ISOs number regarding the standardization. Okay. Similarly, one was released in 2007. These two are the most famous ones. So one was released in 2007. It provides the standard XML representation for metadata. So what it means is now my data here is looking in red color. Maybe if I okay. So if you see here, the color is based on the population density here. Okay. So this is an attribute. This is a metadata of your data. Metadata means the attribute data of your data. Okay. So this data, based on this, I have given it a symbology, a color. So there might be some permitted colors. There might be some permitted font. So how the styling can be done? What are the things? What is the fonts allowed? What is the colors allowed? All of this will be available in this other one. That is the ISO 19139. So it has been withdrawn for some reason, maybe. Okay, the new version is in 2019, it got published again. Okay, but the number is same. Okay, so everything is in this book. Similarly, for this standard, everything is in this book. Okay, now there are some institutions. These are not much active in India, but they are, for example, these are US institutions. So what they do is they check the regulation of it. The standard is with ISO. You have registered your standard with ISO. So if you remember, OGC defined some standards and they registered their standards with ISO. Now, if other companies, for example, ISRI, for example, some company, if they are following the standards or not, it is checked by these companies, Inspire, FGDC. Okay. Now, there came a new understanding about this thing. For example, I just said you, with time, GIS data evolved, right? So with time, the GIS community started understanding that there also needs to be something about the statistics about the data. For example, in maths, you do simple mean median mode, okay? But when you are doing visualization, when you are doing spatial data, the dimensions of statistics increase, okay? The dimensions of statistics become very vast. Now, what I mean is, for example, you have this data here. Now, this is not just some average values, you also have this locational value here. So there are many method in statistics that now you can apply to this, and you can coin out, you can find out different kind of terms, different kind of values, probabilities and everything, right? So based on that spatial data, the spatial community had this understanding now that there needs to be a statistic standardization, that how the stats of a spatial data be defined. Okay. So it was first in 2010, like in Brazil, their National Statistics Institute, it did something about it, and it was called as a Global Geospatial Information Management. Okay. Now they regulate the statistics of the data, and it comes under the United Nations Statistical Department and UN Cartographic Section. Okay. Now, one example of the standardization process and the statistics regulation, one very good example is the Australian counterpart of it. Okay. Now, Australia has in a very clean terms, defined it in a form of this triangle chart. Okay. So they have taken all the points, and for example, if you are doing geocoding, geocoding means the location. Okay. So some authorities and the local body has agreed upon which formats they should be working on. For example, OGC has standardized 10 formats. Okay. But the Australian local institute says we will be just working with only 4 and 5 out of those 10. Okay. So this is their common agreement. For example, for geocoding, it can be latitude, longitude, it can be northing. What I mean is, it can be either in northing easting or in northeast, maybe some other kind of format. Okay. So then the recorded data, how to manage that data, what format it should be, that management. Okay. Common geographic boundaries. Now, for example, if there are two provinces in Australia, okay, so they have defined how the boundaries format and which format should be used, and how the statistics of it will vary. Okay, data interoperability. What I said is like, uh, for example, KML should be convertible to SHP, and the data inside. For example, it is a string. How to convert it into something another format. So they have created this statistical spatial framework, and this is developing with time. Okay. So this is all about metadata, but the most important thing you need to remember is that there is something called as OGC, which regulates the statistical data around the world. Sorry, statistical, no, the GIS data around the world. Everything that is being done is based on the regulations given by them. And that regulation is in a standard format. It is stored in a documentation with international standards of organization. Okay. And currently the trend is that we are moving forward to understand the statistical part of GIS. Okay. Now, I have one or two seniors. They are working in University of Southampton in UK. They are completely working on developing the statistical references in GIS. So they did a PhD on this same topic, and now they are doing their postdoctorate in this. Just imagine. So they are working with OGC and the British government to form some standards of like for example, form some basic standards of everything. Now, as I said, vector files is now a very basic thing, but in GIS you are always coming up something new, some maybe coding development, some programming things or something. So when you are defining a library in Python, okay, then also you need to follow these rules. Maybe I am a person, I am defining a new library in Python for people to use, okay. So I have to follow the guidelines of OGC. It is not like that I can just create my own library. If maybe if it does something wrong, it can be held upon me that you created something wrong. Okay. Hmm. So this was this part about spatial data infrastructure. I hope everyone is clear. If anyone has any doubt with it, just let me know right now. Otherwise, we'll move ahead. Any doubts to anyone? Okay. So after this, the next thing is to understand the geometries in GIS. What I mean in geometries is there is this part in your curriculum that says clean and document spatial data. What do you mean by clean here? Okay. So we understood the ISO metadata here before. Now evaluating the data. Now what happens is, let me share an example with you. Uh, First of all, you need to understand the definition of the word topology. What is topology? Okay. So it is the mathematical relation. I'm sorry, I said the word mathematical, but in the computer terms, it is mathematical relation only. So it is the spatial relation between geographic features. For example, if I made this, if I created this point and I created this line, okay. So this one feature, this point is overlaying this line. Maybe I created two polygons, okay. They are adjacent to each other. They are touching at one point. Maybe they are not touching, so they are away. So how this features are to each other, their spatial relationship is called as topology. Okay. Now, for example, if I tell you, if I maybe this is one polygon of a city, okay, and uh, this is one river going through it. So if I ask you, how will you define the topology of this? Then you can say because first you need to understand that this is one feature, this is another feature. Okay. You can say that the river is intersecting the polygon at four places. That means is it is passing through the polygon at two places. Okay. The intersection points are four, right? This and this. And intersection areas are two, this area and this area. Okay. So maybe you can define percentage that 30% of this river falls into this polygon. So the spatial relationship of two features, it is called as topology. Okay. Maybe if I create this well, maybe this house, and I create this building, another building, and this is a city. So the topological feature of these two with this is that it is contained inside of it. Okay. So topology is broadly defined into three things: connectivity, we also call it as overlay, adjacency, or containment. Okay. Now, why do we need to have an understanding of topology? So, what happens in GIS, if you have been working in digitization, or you know what is the meaning of digitization. For example, there is a real life feature, okay, and you are digitizing it. If it is a large scale project, or maybe you automated it, so the result that was produced, it may have some errors. So, what happens is, so in spatial data, you can have two types of errors. One is location error. So, what do I mean by location error is, for example, this school is at the actual location is at x comma y, x1 y1. Okay. But maybe on ground I said that this is this, but maybe you took a satellite imagery. Okay. Maybe you took a satellite imagery, or you used DGPS to, not DGPS, simple GPS. And maybe this point is being shown to you here, and the x and y is different from this one. That is, it is x2 and y2. So what does it mean? It means there has been a location error. So one kind of error that can occur in GIS is locational error. It can be due to human while collecting data, maybe while if you are taking GPS, or it can be a problem of manual digitization. So maybe you had to create a point here, but by mistake you created a point here. Okay. Or maybe the base map that you were using, that was not accurate. Okay. So there can be many possibilities. So as I said, one is location error, the other is topological error. Now, what do I mean by topological error? So, topological error means, for example, you are digitization. These are some houses. Let me create it with the, okay. This is some real on ground houses. Okay. Now, while digitizing it, so maybe you were given the task to digitize it. What you did was you created this polygon and you overlapped this upon this one maybe. So this is the polygon of this one, and you overlapped. Okay. So now there is an extra area. So topologically it is wrong. According to ground, they should have been two separate polygons. Okay. Also, there can be another case. For example, you created a polygon here. So, for example, you created a polygon here and you left some gap. Now there is a gap between these two polygons. It should have not been also there. Okay. So these are some topological errors. Maybe you created it by via automation in Python or something. Then also these errors can occur. Okay. So one common, very common error during digitization is, for example, I have to create a maybe I have to create road. Okay. So let on the ground the road be this. So this is how the road is actually moving on the ground, real road. Now, when I'm creating this in GIS, the problem I'm doing is maybe I'm not so good at digitization, and the problem I'm doing is that I create a road and then I leave some segment here, and then I'm creating another road here, and then I'm also leaving some segment here. So you see that now you see that there are some topological mistakes here related to ground. They should not have happened. So there is some topological error here. Okay. Now there are some common types of error that occur. Um, Now let me give you example. Just for example, look at this one. So you were supposed to create something and you were supposed to create a point on it. Maybe you created a point a little inside or a little outside. Okay. So it is not exactly on it, but you had to create it on it. So let me give you example. Now I'm creating a uh, maybe this is a highway. So and it goes like this. I have to show the toll toll barriers on this road. Okay. So maybe I say one toll barrier is here, one toll barrier is here, and I say the third toll barrier is here. So the toll barrier has to be on the road, right? It cannot be away from the road. So in these three features, this is correct, this is correct, and topologically this is wrong. So how you correct it? That is, you move this over the line. So you did a topological correction. Okay. So topological correction is based on the logics. Logics means the real world understanding of it. So uh, if it was not the toll, because the tolls are on the road, now you had to shift it over it. Maybe it is a school point. The school is, so the school should be not on the road. It should be away from the road, right? Then these 2 points will become wrong. Then they are topologically wrong. So there is also a logic behind this topological error. Got it? So one is this one, that it was not on this. You can drag and move to resolve it. So sometimes there are another, how to tell you is, for example, this feature, if you see here, uh, okay, when someone created this data, what they did wrong was, in actual, all these lines these lines, they should have been starting from a single reference line. Okay. So when someone digitized this data, they were in a hurry or maybe something, right? They created this error that they just kind of the straight road and they changed it to a something like this crooked one. So then you corrected the topology and you gave it a straight line. Okay. So for example, this was the, for example, this has to be the state highway and these are the link roads. Okay. So state highway is most necessarily straight. So here you have to correct the topology. Now what happens is there are many types of topology, many types of topological errors. This can be one, this is between point and line. This is line and line, right? Similarly, point and polygon, point and line again. Okay. So one common example is, for example, uh, I create this road network, and according to how the boss wants the data, the road network at every, this should be a separate feature. So what he means is every line should be a separate feature. Okay. So this is a separate feature. This is a separate feature. It has its own length. So you can understand better the length of this area. But somewhere someone did some problem, or maybe due to automation there is a problem, that somewhere it became, this turned out to be one single element. So when you are now calculating the length of elements, it turns out that this whole area is maybe 100 meters. But you were looking for the values between every edges. So according to this, the value that will come here, it will be wrong. That will not be suiting your data because you were looking for values between edges. So because someone digitized it wrong, now you have to rectify it. You have to break this line into two at this point. So there is something called as split. There is something another called as split at vertex. So there are features inside of ArcGIS and QGIS. Okay. There are many features that you can use to correct the topology. Now maybe there are 1 lakh roads. Okay. 1 lakh, 1 lakh such points. Okay. And out of 1 lakh such points, there are 20,000 such points that the user forgot to break them. Now, at 20,000 such points, there is a error that the length counted will be, for this will be as a single feature at 20,000 places in this features. Okay. Now you can directly use the split at vertex for this whole, and it will be splitted at vertex. So all the features will be splitted at vertex. So this is how you resolve the topological errors. Okay. There is this another example. So when I did my first job, it was like 1.5 years in digitization. Okay. We came across this one a lot. So we were doing cadastral mapping, and in cadastral mapping, what the digitizer used to do is many of the people, uh, what they would do is they will create land parcels and they would forget to join it. There would always leave some space. Maybe this is, for example, Maybe let us say this is one land parcel and this is another land parcel. So if you see, whosoever digitized, he did this mistake. If I have to calculate the area of these polygons, it will not be calculated. It will call it as invalid geometry. It is an invalid polygon because it is not closed here and I will not be able to calculate the area of this. To rectify this, I will have to join them. Okay. So maybe such a error is at 1 lakh places at in my data. So there is something called as undershoots. So you call it as undershoots. This that they were about to join, but it got left that they are not joined. So this problem is called as undershoots. So in ISRI and sorry in ArcGIS and QGIS, you can fix the undershoots. We give a threshold value. So what threshold means is if any vertex is maybe 1 centimeter to any undershooted point like this one, it will automatically join it. Got it? So the data will get resolved. Similarly, we came across the problem of overshoot. Now it is something like that someone created polygons and they created some extra lines. Now if you see at these 2 points, there is a line that is extra. There is a line that is extra. Now, for example, I have this analysis that I want to do. I want the perimeter of this polygon. Okay. I want the perimeter of this polygon or line data, right? What will happen is it will take in the perimeter. It will take this, 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 and this. So this will add up as a error. So you can use overshoots too. So this problem is called as overshoots. So you can also rectify overshoots in like if this problem is occurring at many places in your digitized data, you can clear it. Okay. Now, similarly, there is directional features. You can change directions, intersection errors, missing points. Now, what happens is, uh, for example, this is my data and I have points at every pixel. So, uh, for example, maybe let me give an example. Let me say that this yellow color is not my. Let me say that you sent someone to the field and they brought back the number of people living in each houses. Okay, so there are many houses here. So let us consider each house to be the size of a pixel. So at every house, they found out the number of people living there and they gave you a value. But they forgot to do survey at some places. They forgot to do some survey at some places. Now, if you use this whole into as a layer, if you want to convert this into a raster maybe, okay, then it will not work because these values are null values. So there is like data missing. So data is missing here, right? So missing data. So what you can do is you can apply different intersection techniques. You can apply interpolation techniques. So you need to fill that data so that you can do the next processing. So that is also a part of topological correction. Got it? Now, there can be some other kinds of topological common one is, as I told you, undershoots. So maybe at 2 points you forgot to join the data, or maybe you have two layers at the same segment, duplicate line segment. Okay, unlabeled region. For example, this data should have been like this. There is a spike, or maybe there should not have been something like this. This is called a dangling node, and there are duplicate label points, overshoot, pseudo node. There should not have been any vertex here. So, for example, if it is a straight line and someone places a vertex here, so that is also wrong. That is a pseudo node. Okay. So, this is one example. This is before editing. So maybe you have very big data. This is just one part of it. And you just applied one simple operation, that is under correcting the undershoots in QGIS, and it connected all the nodes, right? So your data is corrected in one step only, all the data. Now I told you that the data is based on the logic that we are using. So sometimes what happens, corrected data may be unacceptable for mapped images. What I mean is, maybe let us say I have these, sorry, let us say I have these roads, okay? These are roads. Now, what happened is someone forgot to connect them. So, someone forgot to connect them. So, there should have been these roads were complete if they were connected here. Okay. But in actual maybe in on actually ground, this street, this alone street, it ends here only. It does not need to be connected. Okay. So in that case, if I apply this topological correction, what will happen? Because I am applying the topological correction on complete areas, right? On complete file. Now this computer will join everywhere because it falls under the threshold. It comes under the threshold. But now this becomes unacceptable. That is, it is an unacceptable map image element. Now I need to rectify. Maybe I removed 100 errors, but I created one error. Got it? So this number is not certain. Maybe you are removing 100 errors and you are creating more than 100 errors. So you need to be careful about your data. You need to know the logics, how you are apprehending, how you are manipulating your data. Okay. Now there are some other types of editing also available in QGIS and ArcGIS. Now what it means is, for example, you had a curved line, okay? You have this kind of data, okay? And you want to do, this is maybe a river, okay? This is a river, and you want to do some analysis, and the analysis will only work if you have a sharp boundary. What I mean to say is, sometimes you need the boundary in different formats, okay? So there are algorithms. I can convert this kind of data to this kind of data. This is also topological modification. Okay. Now, for example, uh, let me say this is the boundary between, this is a boundary between two cities. This is one city and this is another city. This is the boundary between two cities, one and two. Okay. And you don't, this is maybe 40 kilometers long. Okay. And you don't have the time to digitize it. Okay. Now, what you can do is, Mhm. you have this as a line feature. You already have this as a feature, sorry, not line feature, but you have this already as a vector format. Okay. Now, you want to give a proper boundary. You don't have the, you don't, you can't represent this data as this zigzag boundary. Okay. So for some reason, okay, then what you can do is this algorithm that is there in the QGIS and ArcGIS, you can just directly use that algorithm and it will straighten your line. It will create a straight line here and give you the straight line. So sometimes you need to do modifications in your data. Also, maybe someone gave you the river in this format and you want to change it to curve like this, you can do that also. So there is a reverse algorithm also there. Okay. Now, this thing is called as line simplification, and it was created, the algorithm is called as Douglas-Puker algorithm. So this came in one time in GATE also. Name one line simplification theorem algorithm, and it was Douglas-Puker. Okay. Then the next thing is line densification. So it is inverse. As I told you, if you have this, you want to densify your line, that is, give it more curve. You can change it to the reverse of it. Then there is line smoothing. Okay. Now, what happens in line smoothing is, uh, similarly to this one only, uh, you give an equation here. Maybe, let me say, this is your data, and somewhere it is very abrupt and like this. Okay. So when you use line smoothing, it will follow a equation. You have to give an equation. You need to choose a model. So once you choose that model, it will follow that model, and according to that, it will create the line. So maybe now it smoothened it and it is more circular. Okay. So it gives the line more curve. Got it? That is called as line smoothing. It is based on a mathematical function. So another one is transferring map features from one to another. So this is, for example, this is a city maybe. Okay. So I have this, uh, maybe this is a forest area. So I'm just taking this file and putting it to some another kind of data. Okay. That is transferring of the feature file. So it is also very common. Then we have transformations. It is also a part of the topological relationship. Now, transformations, practically you have done transformation. Okay. Now, but in theory, you need to understand these two words. Uh, Maybe that is in the next one. Let me give you an idea. So, reduction of coordinate pairs required when data has been captured with many vertices for a feature. Okay. So what happened is, you wanted to create a line. Okay. You captured some data and that data was not in line with your uh, the line that you created with. What I mean is, for example, these are some points. Okay. So these are some points. And now, for some reason, your analysis you had to do was you had to find the maximum points where you could create a line. Okay. So you took a line and you created it. So this will be used in regression also, in linear regression. Okay. Now, for some reason, you had to create a line. When you will do Python statistics and everything, right? You will understand what is linear regression. So you created a line here. Now these extra points, they are of no use to you. Okay. So these points now are of no use of you. You can delete this data because your data is because the data that you want to form is based on the points that are here on this line. Okay. So reduction of coordinate pairs required when data has been captured with many vertices for a linear feature. Okay. This process of reducing the points is called as weeding. Okay. One another example of reduction of coordinate pair is, now maybe I had my data like this. So in a curve, there are more points than in a straight line. And for some reason, I had to create a straight line. So I created a straight line. Okay. So in this segment, there are more points than in this segment. Okay. So what is happening is we reduced some data. Okay. That is called as weeding. Also, thinning of coordinates is also required in the map generalization process of linear simplification. Now, what it means is, so maybe if you see this, it is crooked, right? But when I am out at a certain zoom level, if you see, it is crooked here. Can you see it is crooked? When I am out at a certain zoom level, now it has been generalized as a, at this zoom level, I can have it as a straight line. Okay. So thinning, uh, thinning of coordinates is also required in the map generalization process of linear simplification. Okay. Now, you can try this in Google Maps. So when you open your Google Maps, just look at some area, it will have some crooked lines, and as you zoom out, it will turn into straight lines. Okay. Now, there is two very important concepts, that is geometric and geometric transformation. One is called as rubber sheeting and other is called as warping. You have done both of them, but these terms are very important. Even in GATE, this word rubber sheeting has been used. Now, if you remember, there was georeferencing. Now, if you remember, there was an image, you took some ground control points, you placed it on the right location. Okay, you placed it in the right location after you moved it. Okay, so that moving that geometric transformation of the complete image, that thing is called as rubber sheeting. So, do you remember there was some polynomial 2, polynomial 3, spline? There was some kind of stretching of the sheet. So, stretching that data layer to meet another predefined control points, okay, that is called as rubber sheeting. And mind me, this is a very important term. Sometimes some people do not say georeference. They talk like just complete the rubber sheeting process. Okay. So it is just like rubber sheeting, it means georeferencing only. Okay. Then is warping. So warping is giving the coordinate system to it. So maybe you have some data. It is in WGS84, but it should have been in projected coordinate system. So just changing the coordinate system of it, it is called as warping. So even if you see in QGIS, I think warping. So this reproject is by the name of warp. Okay. Warp is something similar to wrap. You are trying to wrap it in a different position. I remember it like wrap, but it is warp. Okay. So it is very important to remove the topological errors, to not create topological errors. It is very important that you are working in a single map projection. So if your map is in WGS84, your data should also be in WGS84. Okay. So the project coordinate system and coordinate system of every file, it should be common. Okay. Now, when you will be learning SQL, you will get to know in PostGIS, that is, eh, for example, for journal analysis, we are using ArcGIS, QGIS. So when you are working with code language of SQL, you are working in PostGIS. So in PostGIS, there is a database manager where you write your SQL code. So your data, for example, your feature layer, your vector layer will be here, and you have to write some SQL code here. Okay. Now, this topological modification that we just studied, this topological modification, all these, they can be done in SQL also. So maybe you are working in SQL, you can do all of them in SQL also. Okay. So I am sharing you one exercise. This exercise, this is your homework. If you do it, it is very good. So this is two parts. Now, if you remember Thyssen polygon from interpolation, right? So this is a area mean fall rain, areal mean rainfall. So this would be better to also understand the AQI also. For example, AQI, if you have the data in points, so do not download the data here. Just directly go to this part here. Directly go down and the data has been given here. Do not get into the problem of downloading the data of yourself. You can find the data here. All the data is provided here. So just like AQI, you have mean rainfall. So at all these points, you are being given the rainfall data. Okay. So from this rainfall data, you have to create an interpolated Thyssen polygon. Okay. So that polygon would look something like this. So similarly, if it was not rainfall data, if someone is telling you that how to work with AQI data, what you can do is for those points, there is some AQI values. From those AQI values, you can create a Tizen polygon and then clip your city from it. So when you clip your city, so this is every polygon has a value. Now you know the variation of, for example, AQI in your city. At this place, if you click here, the AQI is this much. So from points, you were able to generate a map of AQI for your city. Similarly, here you are generating a map for mean rainfall for your city. Okay. Now what happens is we just read about cleaning the geometry, some topological errors. Okay. So while creating this Tizen polygon, there will be created some topological error. That is, at some places the at some places it is not joined completely, or maybe there is an undershoot or overshoot. Okay, so it will give you an error when you will do some intersection or something. It says the in geometry is invalid. At that point, you have to use one of the tools that is inside QGIS, that is fixed geometries. So what it does is it joins all the dangles. So what I mean is, so for example, this is one polygon and this is, it should have been joining it here. Okay. It didn't join it. So this fixed geometries, it joins it. Okay. This is one tool in QGIS. So similarly, there are many tools for all the operations that I just told you. So once you fix it, it will be working. Now it gets joined. Okay. Then you can finally process your data and you have the final values. Okay. So just try to do this project, and if possible, just let me know in the next class. And tomorrow is a holiday. So we will be meeting on Friday. So, okay then. Happy Christmas to all of you. If interviewer asks what is topology, okay. So you have to say that topology is the spatial relationship between two features in GIS. Okay. Just remember, you have to say topology is the spatial relationship of two features in GIS. It can be intersection, it can be overlapping, or it can be disjoint. Okay. And there can be many more types, but the broad types are this one only. One is intersecting, one is overlapping, one is disjoint. They are not connected, right? So, but the basic is it is the spatial relationship. Okay. Any other doubts, please? Okay, then take care. We will see each other on Friday.